Well, at our meeting today, I've decided to tell you about some of the aspects of the history of nuclear engineering education in this country. I've been with nuclear engineering education ever since the beginning. First as a graduate student at MIT, and then as a professor at Texas A&M, Northwestern, and here at the University of Illinois. In 1951, there was an article in a chemical engineering journal written by Manson Benedict. The title of that article was, "What's Holding Back Nuclear Power?" Manson Benedict was the engineer who was given extensive credit for the success of the gaseous diffusion plant at Oak Ridge. The gaseous diffusion plant was built to produce enriched uranium for the Manhattan Project. And Benedict was instrumental in the success of that plant. The Oak Ridge plant was built there because there are many electric motors in that plant, and they needed a source of electricity to run all the electric motors. And the Tennessee Valley Authority then had the capacity to produce the electricity. In 1952, the early part of 52, Walt Whitman, who was the head of the chemical engineering department at MIT, hired Benedict to offer an option in nuclear engineering in the chemical engineering department. Now, the term nuclear engineering is one that I did not hear first at MIT. In undergraduate school, I was on a combined plan between Williams College and MIT. In the 5 years, you got 2 degrees, and the purpose was to combine a liberal arts education with a technical education. So I spent 3 years at Williams and then down to MIT for 2. In the spring term of my 3rd year at Williams, I went to see my physical chemistry professor, and I had a question for him. That question was, if I studied both chemical engineering and nuclear physics when I got down to MIT, what would I become? And he said, there's going to be a new field, and that new field is called nuclear engineering. And so when I got down there to MIT, I had already heard the term before they ever started it down there. Well, Benedict started then with a course in nuclear chemical engineering in the fall term of 1952. Well, in my first year in graduate school, I was concentrating in chemical physics because I didn't know that Benedict was starting to offer nuclear engineering, and that was what I actually wanted to do. So when I found out that he was going to offer degree programs in nuclear engineering, I went to see Professor Benedict, and he said, okay, you're in right away. So then in the fall term of 1953, I started to study nuclear engineering at MIT. Now, Benedict was the first professor, and Tom Pigford then was an assistant professor who helped Benedict. The first courses that they gave were nuclear chemical engineering, and then they gave a course in reactor engineering. And the reactor engineering course then covered the neutronics and heat transfer and control and so forth. It's analogous to the Zonsky book now on reactor engineering. Those were the first 2 courses. Now, Benedict wanted to have a nuclear reactor for experimental courses. So he hired in a fellow from Los Alamos. That fellow was Tommy Thompson. Tommy Thompson had gotten his undergraduate degree in physics at the University of Nebraska, and when he was an undergraduate, he was also an All-American halfback on the football team, which was an unusual combination, physics and All-American halfback. Well, then he went to graduate school at Cal Berkeley, and when he finished that up, he went to work at Los Alamos. Well, Manson Benedict hired Tommy in with the explicit purpose of now designing and building a nuclear reactor for the nuclear engineering effort at MIT. So Tommy came there, and I was assigned as a research assistant with him. And now at Argonne, there was a heavy water reactor type called a CP5. Tommy didn't want to buy a reactor. He wanted to design it right there in the department, that is, do the preliminary design, and then have it built by a contractor. Well, I got the job as an RA to do calculations in support of the preliminary design for the MIT research reactor. And I did several calculations. One calculation I did was on the worth of the control rods. Now, I didn't really have the data to make a prediction that was going to be right, but Tommy told me they measured the worth of the control rods, and he said what I had calculated was actually what they measured. And that was really a minor miracle, because I didn't really have the data that I needed to do that calculation. Now, Tommy Thompson was the guy who recommended to the AEC that all nuclear power plants have containment buildings. And we designed the MIT research reactor to be in a containment building. That building actually operates then at a pressure which is below atmospheric pressure, so if there's any leak, then the leak is from the outside to the inside. Now, also, at that time, the exclusion area around nuclear reactors was the order of miles. Well, the exclusion area around the MIT research reactor was going to be about 50 feet. And that's because it was going to be right in the city of Cambridge. And so I got the job then of designing what's known as a shadow shield. A shadow shield is a concrete wall on the inside of the building, and I designed that to be 33 feet high and 2 feet thick. And the criterion was then that if all the volatile fission products were released and distributed throughout the building, then a person walking on the sidewalk would not get a dose of radiation beyond an allowed limit. So I designed that shadow shield, and Tommy was happy to have it because then he put a track around the top of it, and then he put a crane up there to carry all the heavy stuff. You know. Now, at that time, there was a reactor called the Materials Testing Reactor, the MTR, and that had fuel elements which were demonstrated to be good. And then we decided that we would use heavy water as the moderator and the coolant. And the reason for that was that the neutron lifetime in a heavy water reactor is much longer than in the case of a light water reactor. So that was a safety aspect then in that design. So we worked out the preliminary design, and then we had to get a building permit from the people in the city of Cambridge to construct it. Well, we wrote a report called a hazard summary report. It was 127 pages long. Tommy Thompson and I and Manson, Benedict, and Tom Cantwell were the 4 authors of that. And then we took that hazard summary report down to the Advisory Committee for Reactor Safety in the Atomic Energy Commission. And they then okayed putting the reactor right in the middle of Cambridge there. So once we then had the approval from the Atomic Energy Commission, we then went to the people in the city of Cambridge, and they couldn't say no at that point, so we got the building permit. So then the contract to actually build that went to a company called American Car and Foundry. And the president of that company was Harold Etherington. And Etherington had actually worked with Fermi in putting together the original pile in Chicago. And then they had an engineer there by the name of Joe Dietrich, who was very familiar with the CP5. So the final design then was done at American Car and Foundry, and then they constructed the reactor. So after that then, Benedict wanted to continue to grow the faculty. Well, he needed somebody who could do the theoretical reactor physics. There was a professor in physics by the name of Francis Friedman, and he had worked with Fermi, and Franz Friedman was the guy who invented the multi-group diffusion model for analyzing critical assemblies. Well, Friedman was not interested in participating in nuclear engineering at MIT, and so Benedict then got a hold of Irving Kaplan, who was giving courses over at Harvard, and Irving Kaplan told him about a fellow out at Livermore by the name of Melville Clark. And Melville Clark was a theoretical physicist who had gotten his degree with Julian Schwinger at Harvard. He was one of Schwinger's early students at Harvard. And so Benedict interviewed Mel Clark, and Mel Clark was developing Monte Carlo methods at Livermore. And so he hired Mel, and then Mel became my advisor. Okay. And then he eventually also hired Irving Kaplan. The early courses in nuclear physics were given by Robley Evans in the physics department. And that real thick book called The Atomic Nucleus contained the material that was contained in those courses. Robley Evans also gave a course in health physics. And we all had to take the health physics course and the nuclear physics courses from Robley Evans. In mechanical engineering, Warren Rosenau did the heat transfer and conduction, convection, and radiation heat transfer. So that's where we got the advanced professional study then in heat transfer. Okay, well, then time went by. I was among first of 3 civilian students in nuclear engineering at MIT. Most of the early students were naval officers that were sent there by Admiral Rickover. They were going to become the people who ran his nuclear navy. So there weren't many civilians to begin with. And the first 3 civilians were myself, Kent Hansen, and Flo Morality. I finished my thesis before Kent and Flo did. I made sure that that happened, to tell you the truth. So then I got the first degree. I defended my thesis in December of 1957 and then got the degree in February of 1958. And as we were walking back from the defensive thesis, Manson Benedict said, "You're the first one." Well, they remained then a concentration in the chemical engineering department until 1958. And then Benedict told me they had to get one doctoral student through before they could become a department. So after they got me through in February of '58, then they became a department in the summer of 1958. And that's when the Department of Nuclear Engineering then was created at MIT. And it's been going ever since. In 1983, we had the 25th reunion, and I went back to Cambridge, and that really was a way to honor all the contributions that Manson Benedict had done. Well, then I went to work, and in the spring of 1960, Bob Cochran hired me in at Texas A&M. Bob had been hired to start a nuclear engineering department down there, and he had gotten his degree at Penn State with Brazil, and he built a swimming pool research reactor for Texas A&M. That was not built in College Station. It was built out by the airport. And Bob wanted somebody to handle the theoretical aspects. He was going to do the experimental stuff, and he wanted somebody to handle the theoretical aspects, which I then did. And in the first 2 years I was at Texas A&M, I created 6 new graduate level courses in nuclear engineering because there was nothing. I actually started out in April of 1960 because he wanted me to have time to create the courses during the summer of 1960. So that I did. And then in the first 2 years, I created 6 courses in graduate level reactor theory, graduate level fundamental principles of nuclear engineering, which included the heat transfer and the thermodynamics of fuel cycle, of power cycles, and then also some theoretical plasma physics courses. So after being there for 3 years, then we relocated up to Evanston at Northwestern. Ernie Clemma hired me at Northwestern, and nuclear was offered as an option in the science engineering curriculum there. We didn't call it engineering science, we called it science engineering to emphasize the fact that the basic science content of the curriculum was much larger than the normal engineering science curriculum. So Ernie had worked at Los Alamos during the Manhattan Project, and he told me that his instrumentation was the one that was the closest in that was not destroyed in the Trinity test down at Alamogordo. So Ernie was an experimentalist, and he wanted me to do the theoretical part at Northwestern, which I did. And Ernie and I had a very good relation. I really admired that professor. Now, in the spring of 1966, I got a call from Marv Wyman here at Illinois. And he said they needed somebody with my interest and that I want to come to Illinois. And I said I didn't know, but I think I should come down and find out what the issues are and give a seminar. I got an offer then within a week to come to Illinois, and that I accepted. Now, when nuclear engineering started here, it was not a department. Nuclear engineering was started as a graduate degree program only here, and it was run as an interdisciplinary program at the graduate level. Master's and doctor's degrees were offered. And the reason it was an interdisciplinary program is because in 1958, Ross Martin hired Marv Wyman and Felix Adler. Felix Adler was a theoretical physicist, and Marv Wyman was an experimental physicist who actually got his PhD degree here. And at that time, Marv Wyman was working at Los Alamos, and Felix Adler was working at General Atomic. And Ross Martin brought those two people to begin the nuclear engineering interdisciplinary program at the graduate level. And then that program was run by a committee. And then Marv Wyman was the chairman of that committee. And then there were people from the different departments who contributed to the program. In mechanical engineering, Bates Chow helped out. From electrical engineering, Dan Hang helped out. And from theoretical and applied mechanics, George Costello helped out. So, and Bob Bowl was in metallurgy, which is now called material science. So those fellows all gave courses for graduate students now who are getting their degrees on this interdisciplinary program. And Bill Everett was the dean at that time, and he strongly supported the program because he believed that interdisciplinary programs were possible at the graduate level. And so we were the first model for Bill Everett of that kind of a program. Well, the time went by, and then the program became a department, and then we finally put in an undergraduate degree program. I was the guy who was arguing for the implementation of the undergraduate degree program, which we did. And after that was then we became a department, and we're now the department that we are. So I think that's really kind of a brief rundown on some of the history of nuclear engineering education and the people who were involved and made it possible for students then to have opportunities to study nuclear engineering. Okay, now the department has initiated a campaign to augment the endowment. The objective is to not only offer scholarships to undergraduate students, but also to be able to offer now fellowships to graduate students. So the endowment was established in 2002, mainly with the contributions from alumni. Okay, and as time has gone by, the endowment fund has grown, and we have been able to offer 1 or 2 undergraduate scholarships for many years now. And now the campaign that Jim and Susan are doing has the purpose now of augmenting the endowment so we can also offer fellowships. And if you're able to help out with that, we sure would appreciate it. So thanks very much for listening.